Okay, so in this video we're looking at finding percentage increase and decrease of numbers, usually kind of in real life situations without using a calculator, and that's really important. And look, if you can find 1% of a number, then that's you can sort of solve any problem. But actually, there are 4 kind of useful percentages that we can find to begin with. So I'd make a note of these on your notepad, and then we can go through into a couple of examples. So yeah, 4 key percentages. The first one is 50%. So find 50% of a number, you can divide by 2. 25% we divide by 4, 10% we divide by 10, and then probably the most useful one is to find 1%, because if you find 1% of a number, you can always scale up easily, right? Let's say you wanted to find 33% of a number. Well, if you have 1% of a number, you can just times through by 33 to get 33%. It is called the unitary method, okay? So, right, to find 1% of a number, you divide through by 100, but, sometimes they just ask you to find more easier ones like 25%, you can just divide through by 4. So these 4 ones here are really important to make a note of, and probably the most useful one that I use a lot is to find 1%. You divide through by 100. Right, let's look at 2 examples, and it's just going to be 2 examples on this video. So you can, if you want to, you can give those a go yourself, or if you want to go through them with me, then that's going to be good. Okay, so the first one is percentage increase, non-calculator, really important, and the second one is percentage decrease, non-calculator. Let's get into it. So the first one is Sam has paid £45,000 per year, okay, and he's going to receive a 4% increase, so that's a really important bit of information, in the amount of money he has paid. So work out how much money Sam will be paid per year after the increase. So I want to increase £45,000 by 4%. Well, to find 4%, let's go and find 1% of that number first, okay? And to do that, to find 1%, which we've just seen on the previous slide, we've got to go and divide our number by 100. So 45,000 and divide through by 100. Well, if you divide through by 100, you just knock off the zeros in this case, the first 2, because we've got 2 zeros. So 1% is going to be equal to, and we're looking at money here, so £450. So that is 1%, but I want 4%, so I've got to go and times through by 4. So I've got to go into £450 and times through by 4. Look, if you're good with calculations in your head, you can quickly work out that's going to be £1,800. But I would always recommend, right, in exams, particularly paper 2 and paper 5, non-calculator, right, you're showing you're working, you're making sure we're getting these things correct. So I'm actually going to go and work through how I would model this if I was doing this as a student. So, right, using a method, so 4 times 450, to make sure we're being try not to make mistakes here. Well, 4 times 0 is 0, 4 times 5 is 20, and 4 times 4 is 16, add the 2 is 18. So there we go. Right, that's quite a simple one, but I would always recommend, right, writing and working down, really important. So we've got here, it is equal to £1,800. Okay, so 4% of our number, 45,000, is £1,800, but I want to increase that amount by £1,800. So now I've got to go and do my amount, 45,000. I've got to go and add on 1,800, okay? And again, right, maybe you can do that in your head. Okay, you can see it's going to be 46,800. Let's write things down so we can be sure we're not making mistakes, or more sure it's going to be no mistakes. So 0 is 0, 0, 0, 0 add 8 is 8, 5 add 1, 6, 4 and nothing is just going to be equal to 4. Okay, so after the 4% increase, Sam is going to be receiving a new salary per year of £46,800. Okay, and that is my answer. Showing all my working, making it really clear to the examiner what I'm thinking and using my methods. Because if I did go wrong, if I made a mistake, which could happen, okay, well, you get follow-through marks. So let's just say I got that calculation wrong, which it isn't wrong, hopefully, but you would get marks for following on using the correct methods. And that's really important. We try and get every mark we can in exams. Okay, question 2, let's have a look at it. This one is looking at percentage decrease, non-calculator. So Anna sees a special offer in a shop, where the special offer is if you buy a phone and a case for these amounts here, if you buy both items, you receive a 6% discount. So if you buy both of these, you reduce the cost of it by 6%. So Anna buys both items. Okay, that's useful. How much does she pay? Well, let's begin by finding the total cost of these amounts here, and then we can apply that 6% discount. So again, right, you could do this in your head, but let's write things down, make it really clear what is going on. We're doing 529 add 30 5. A little bit clearer, 35, and we are adding those together. Well, 9 and 5 is 14. 2 and 3 is 5, add the 1 is 6, and then 5 and nothing is just going to be equal to 5. So you can do that in your head, but making it really clear what is going on. I want to discount that, so decrease 564 by 6%. So I want to find 6% first of 564 and then reduce it. Well, let's begin again by finding 1% of that number. So to find 1% of 564, again, we can go and divide through by 100. Well, 564 is the same thing as 564.000, so on and so forth, right? If you're dividing through by 100, that decimal point is going back by 2 spaces because I've got 2 zeros. Okay, so it's going to go to 5.64. So 564 divided by 100 is 5.64. I want 6%. Okay, I can easily go and upscale that because, well, if 1% is equal to 5.64, 6% is going to be 6 times the 1%, which is 5.64. Okay, and definitely here, right, you could do this in your head again. That's fine, but write things down, make it clear what is going on. You're less likely to make a mistake. So let's write this as 564, so 564, and we're timesing through by 6, and let's begin our multiplication. 6 times 4 is equal to 24, carrying that 2. 6 times 6 is 36, add the 2 is 38, and then 6 times 5 is 30, add the 3 is 33. So I've got 3,384, but just using a bit of common sense here, right, 6 times 5.64, let's just use 5.64 to be, I don't know, roughly 6. 6 times 6 is going to be 36. Okay, so it's going to be 33.84. Because if it was 338 or 3,384, right, that's nowhere near 6 times 6. Okay, so £33.84 sounds reasonable in that calculation. Okay, so 6 times 5.64 is equal to £33.84. Okay, well, I want to discount my amount, 564, by this amount here. So I've got to go and perform a subtraction. Okay, and that's going to write out our method. So we're doing 564, and we're taking away 33.84. And to make this a little bit easier, let's go and add on some zeros here and go and perform our subtraction. Well, straight away, there's a bit of an issue here because 0 take away 4, we can't do. That number's going to be bigger than the one below. So I've got to go and borrow from my next number, which I can't again because it's a 0. So I go and borrow from this 4 and turn it into a 3, carry the 1. But still, that's a 0. I've got to go and borrow from this number, make that a 9, put the 1 there. So 10 take away 4 is 6. 9 take away 8 is 1. Bring down my decimal points. 3 take away 3 is 0. 6 take away 3 is 3. And 5 take away nothing is just 5. So after the discount, Anna is going to be paying a total of £530.16. Okay, and if you got that, fantastic. So just a quick video there on percentage increase and decrease without a calculator. I would always say, look, the unitary method, so what I mean by that is if you find 1%, we call it the unitary method, is really useful because you can easily go and just scale up or down by timesing through or dividing through. But, sometimes the questions are easier and it's just like, I don't know, find 25% of a number, well, we can divide through by 4 using this stuff here on the previous slide. Okay, thank you.